We use it literally every single day for watching videos, sending messages, searching for, well, everything. The internet is so woven into our lives that we barely even notice it anymore. But have you ever actually stopped to think about how it all works?
That's the big question, right? So, in the next few minutes, we're going to pull back the curtain on this digital world. And I think you're going to be pretty surprised by what we find.
Okay, so first things first, we have to get rid of a few common ideas. When you think of the internet, you probably picture something like the cloud, right? Some kind of magical, invisible thing floating around us. But the reality is way more down to earth. And this right here is probably the single most important idea to get your head around because it changes everything. The internet is not magic, it's a machine.
That's really the core idea. The internet is a physical thing. It's this gigantic, sprawling, global network of computers and servers, and even your phone, all physically linked together by millions of miles of actual cables, some buried underground, others laid across the ocean floor. It's all just connected hardware.
So, to really understand this giant machine, let's just trace one simple action you do all the time: typing a website into your browser and hitting enter. We're going to follow that one little command on its incredible journey around the world.
All right, so you type in a name. Instantly, your computer sends out a request. Think of it like you're mailing a letter. But that letter needs an address, right? That's where step 3 comes in, the DNS, or Domain Name System. The DNS is basically the internet's giant global address book. It takes the simple website name you typed and translates it into a numerical IP address, which is like the specific street address for the computer or server where that website actually lives. Then your request travels through all those cables, guided by these digital traffic cops called routers, all of them working together to find the best path, until your request arrives at that exact server, even if it's on the other side of the planet.
Okay, so your request made it. The server got your letter asking to see the website. Now it has to send that website back to you. But here's where the system gets really, really clever. It doesn't just send it back in one big chunk. No, instead it uses something called a data packet. Following a set of rules called protocols, the server takes the entire website, all the text, the images, the code, everything, and chops it all up into thousands of these tiny, individually addressed little pieces. So you can forget that idea of information traveling like one giant scroll being unfurled. The reality is much more like trying to send an encyclopedia by mailing thousands of separate, tiny postcards. And get this, each one of those little postcards gets sent out onto the network, and they don't even have to take the same path. Each packet finds the quickest, most efficient route back to your computer at that exact moment. They're all racing across the globe, arriving completely out of order, and your device acts like this master puzzle solver, reassembling them in the perfect sequence in a fraction of a second to show you the complete web page. It is an absolutely incredible feat of coordination. The fact that all of this, the request, the DNS lookup, the data packets flying across the world, and then putting it all back together, happens in like a second or two is just mind-blowing. But if the system is so efficient, that leads to a very common question. Yeah, if it's this brilliant, why do we still end up staring at that loading screen? Why does our video start to buffer right at the most exciting part? Well, it all comes down to real-world physics. First, you've got distance. The further away that server is, the longer that round trip takes for all those little data packets. Second, there's traffic. It's just like a highway at rush hour. If too many people are using the same digital roads, things get jammed up. And finally, connection quality. The physical cables themselves really matter. A new fiber optic cable is like a data superhighway, but an older connection might be more like a bumpy country road. So when you strip it all away, that's what the internet is. It's not magic, it's not a cloud, it's just a massive, physical, globe-spanning network of computers that are all communicating with each other at incredible speeds by sending and receiving tiny packets of information. And what might be the most staggering fact of all is just how fast this whole thing was created. This entire planet-altering infrastructure, this thing that has completely reshaped human society, was basically built from scratch in about 50 years. That's one of the most rapid and transformative achievements in all of human history, which really makes you wonder, if we built this globe-spanning network in just 50 years, what on earth will the next 50 years of connection even look like?